Hello friends, so today we are going to discuss another LeetCode problem. The problem is Univalued binary tree. So what is the problem description? So we are given a binary tree and we have to check whether the tree is univalued. So what does it mean? Univalued means what? So if every node in the tree has the same value, and what we have to return is we have to return the boolean value. So it can be either true or false. So let's take an example 1. So here if we see from the top and if we go down the bottom from at the left side and similarly at the right side, so we can see whatever the value of the root node, that is a 1, and we are having its children and its grandchildren all are having the same value. So that's why for the example 1 the output is true. Now let's see the another example 2. So here if we can see the root value is 2, then its children value left and right is again 2. But if we see the left children and left of left children, so it has the value 5, and that's why it is returning as a false. So it's a pretty straightforward problem. So let's get into the code part. So here we are given a function is univalue and which accepts a tree node, that is a root node, as a parameter. So what we are doing here, so let's say if a tree is empty at the initial state, so we just have to simply return true because empty tree has a nothing, so that's why it is a true. Now what we are doing is we have created a pre-order function over here and it has two parameters. One is the tree node and another its current value. So what it does is, so it's basically a simple left traversal and a right traversal of the tree. So inside this function what we are doing is we are again doing the same check. If the tree node value or if the root is null, then we are simply returning true. And let's say what, so initially if we see over here for the example, if we can consider any of the example, let's say if we consider the example 1 over here, so initially this that is previous value, that is a 1. So we are checking over here with, so whether this root value is equal to previous. So here the root is 1 and again the previous value is also 1, so this condition doesn't get satisfied. So here it goes to this block. So here what we are doing is we are simply doing the left order traversal and we are doing the right order traversal, and we are making sure that whether we are getting true value. If both the sides are true, it means we are finding the similar value on the left of the tree and similar value or the same value on the right side of the tree. In that case only it will return the true, and finally we will get the output as a true over here. Okay, and in case if it doesn't get matched, so either of the tree will return the false at this line. So let's say for example at the right side in example 2, if we get the true as a response over here, but in terms of if we see the left child of child, so in that case, or we can say grandchild, so here 2 will not get matched with the 5, and that's why it will return the false. So false from the left side, that is a false, and true from the right side. But again it is a condition and conditional operator, so it will not go to execute the right part because the first condition is false, so implicitly it will return the false as an output. So let me quickly run this and let's see the output. Okay, so here the solution is super fast and the runtime is 0 millisecond, which is a faster than 100% Java submission. And let's see the test case coverage. So we can see it has covered all the 72 test cases over here. Now let's come to the time complexity and the space complexity of this algorithm. So we are not initializing anything new or any kind of data structure. So time complexity is the space complexity is big O of 1, and in terms of the time complexity, so we are going down the bottom of the tree, so that is a time complexity is big O of height of the tree. So we can consider it as a big O of h or big O of n, whatever it is suitable. So I have posted the solution on GitHub, and I have uploaded the link in the description section below. So if you like this video, please do like and share this video and comment this video, and stay tuned for the next one. Thank you.